We're continuing with section 4.7, example 2. Find two non-negative real numbers x and y such that their sum is 120 and their product is as large as possible. So this one we don't come up with any drawing, but let's say x and y, the variables already given to us, two of them, and so we know that x is bigger than 0 and y is bigger than equal to 0. It says non-negative, means 0 can be included. Other piece of information is the sum is given and the product is supposed to be as large as possible. So what is my goal function or objective function? It's to get the product to be as large as possible. That's the one that I'm optimizing. And so product P equal to x times y is the objective function. Then the other part is 120. 120 is the sum of x and y. That is the constraint. Now let's look at this. Objective function is function of x and y. I don't like that, so I have to use the constraint. That's the limit that I have for or bounds that I have and to solve for one of the variables. This time around, let's solve for y. And then put it back in the objective function. Replace, sorry. And that would be x times 120 minus x. Again, this is going to be quadratic, but we're not using our pre-calculus knowledge from now on. All the way to here, same thing as pre-calculus. From now on, instead of using the vertex of quadratic equation, we use one of the methods that we have. And so which first of all, derivative is always is going to happen. So let's take the derivative. And that is 120 minus 2x. And find the critical numbers by setting that equal to 0 in this case. And getting x equal to 60. And now, let's do a test. Which test? First, domain. Domain is x bigger than equal to 0, and then maximum that it can get is 120. So domain is 0 and 120, closed bounded method, and I have to check P at 0, which is going to be, if I compute right here, I get 0. P at 120, again, if I compute right there, if I plug it in, I get 0. P at 60, which is going to be, if I plug in 60 into here, then I will get basically 60 times 60, which is 3,600, and this is the maximum product that I can get. That's a max value. And the question is asking find two non-negative real numbers, x and y. And so I found x over here, use the equation for y when we solved for y to find y. Y is going to be also 60. And these two are the answers. So we figured out how to solve example 2 when x and y were two non-negative number. What if I remove the two non-negative cause of the question? Then instead of x being bigger than equal to 0, and y being bigger than or equal to 0, you will have x to be any values that you want, and that x and y both are going to be any real numbers, and the other one can, when you add them up together, they have to be only 120. So that when I remove this, the domain becomes everything all the way to the domain is the same solution, but after that, domain becomes negative infinity and infinity. And then over here, I can't use the closed and bounded, closed interval method anymore. Cannot be used. And so what do? The best way is because you already have the derivative, the best way is to actually use the first derivative test. And so when you do the first derivative test, so derivative was p prime of x equal to 120 minus 2x. So first derivative test, f prime and 60, and before 60, you get a positive value. After 60, you get a negative value. Oh, look at this. Increasing before, decreasing after, and no other place that it goes up or down. So there is an actual maximum, max, at x equal to 60. And that's how you figured it out. So if the domain is different,